So now that we have the Bohr model of the atom to start working with, we can start talking about these individual parts that make up the atom. So this is an example of helium, and we can see there's some protons, there's a neutron in here, and an electron. So let's look at some individual parts. So protons, those are the positive parts of our atom. They sit right here in the nucleus in the middle. And they have an average mass of 1. So we count these as 1 when we talk about mass. Neutrons also sit in that nucleus, and they also have a mass of 1. Now, they also are neutral particles. They do not contribute anything to the charge of this atom. And then lastly, there's the electrons, which sit in these orbits on the outside, as Niels Bohr pointed out. And they do not contribute to the mass. So they do not have mass that we're going to contribute. Yes, they are matter. Yes, they have mass. But it's 1/1000th of this proton. So it's contributing so little that we just don't include it, okay? So let's look at these each in a little bit more depth. So the mass of an atom. So when we think about the mass, we're thinking about how much this has, right? So it's a combination of protons and neutrons. So in order to find it, I find the amount of protons I have, I find the amount of neutrons I have, and that should equal the mass of that atom. Now, if I have 9 protons and I have 9 neutrons, my mass is 18. So it's nice and simple calculations. So if I look at this model right here, so this was helium from before, there's 2 protons, there's 2 neutrons. There's also 2 electrons, but the electrons do not contribute anything to the mass for my calculations. So I add them together, 2 protons plus 2 neutrons, and it's a mass of 4. Okay. So protons are really interesting. They're positive particles that sit within the nucleus. They are what defines what the element is. So if I have 1 proton, I have hydrogen. If I have 2 protons, I have helium. If I have 7 protons, I have nitrogen. So anytime I change the amount of protons, I'm changing what the element is. And again, each one of these protons has a mass of 1, okay? If you want to find out how many protons that element has, all you have to do is look at the atomic number. So the atomic number is the only whole number that's going to be on your periodic table. So it may be in this corner, it may be under the symbol, but it's the only whole number. And you should always see a key on a periodic table, which will tell you where the atomic number is. Now, neutrons are different. So neutrons are, again, those neutral particles. They're found in the nucleus. They have a mass of 1, but they do not contribute to the charge at all. They're neutral. Their goal is to actually help with stability. Think of them kind of like a buffer. They sit together in that nucleus so that all those positive particles aren't just repelling and pushing each other away too much. So with this one, if I want to find out how many neutrons it has, well, I know what the mass is. I know how many protons I have, because that's the atomic number. I just subtract them. So this is about 1. So 1 minus 1, there's no neutrons. So in the average mass here, so that's what this is. It's an average of all of those isotope masses. And then we take the protons, subtract the protons, we get them together. So my average mass here is 14. 14 minus 7, there's 7 neutrons in nitrogen most of the time. And then this one over here, I will let you do this on your own, but it's about 197. So 197 minus 79. So if I look on my handy dandy calculator real quick, it is 197 minus 79 equals 118. So the average for gold has 100 and was it 18 or 19? 118 neutrons. Okay. So if I want to find neutrons, we can also write it slightly different. So you will see certain writings on this. I'll make another video about symbols and telling what we have. But we can also write it out in this phrasing. So carbon-12 or carbon-13 or carbon-14. Now, these aren't telling you the amount of neutrons. Instead, it's telling you the total mass, because carbon always has the same amount of protons. It always has 6. Carbon always has 6 protons. Carbon always has 6 protons. It's telling you the mass, because it's also saying if I have 6 protons and 6 neutrons, I'll have a 12 for a mass. If I have 13 for a mass and I have 6 protons, then I must have 7 neutrons. So we can add and subtract these to get together. So this is a different type of symbol that you may see. It's an isotope. So isotopes just mean that they have a different amount of neutrons within them. Okay. And then lastly, we have electrons. So electrons are what I consider to be probably the more interesting aspect of an atom. They are actually what in most chemistry, if you really think about it, boils down to what are the electrons doing. So this year when we looked at making ionic compounds and changing, that also had to do with the same thing. So we have electrons which have a negative charge, they orbit the nucleus, and they do not contribute to that mass. Now ions are just atoms with a charge. And when we look at these, so these are symbols for ions. They have the pieces, we've used these earlier this year. It's telling you how many more protons than electrons we have if it's positive. If it's negative, it's telling you how many more electrons you have than protons. So in this case, 3 plus, there are 3 more protons than electrons. With a 2 minus, there are 2 more electrons than protons. So we can add and subtract based on what we know. So if there are 3 more protons, then I need to subtract 3 to find out how many electrons I have. If there are 2 more electrons, then I need to add. So always think about what's there and what's happening. So there are 3 less electrons here. There are 2 more electrons here. And that's because the overall charge would be positive, and it would be 3 points higher, right? Because there's 3 more protons than there are neutrons. And that's really what we can do. Now, if you see that positive or negative, you have to be really careful, because you have to remember that if you change the number of protons, you're changing the element. A common mistake that people will make is that 3 plus, they will add to the protons. And that is not correct. You cannot change the number of protons without changing what element you're working with. Okay, so be wary of that mistake. Don't make that mistake, okay? And again, if you have any questions, just ask.